Welcome to video tutorials of mekanizmalar. Pneumatic automation plays a very important role in the manufacturing and packaging, as well as many other industries. The pneumatic machines used by large companies are highly optimized for speed and the use of pressurized air. This is because they have highly trained people maintaining these systems. Small companies, on the other hand, do not have this luxury. At a caster manufacturing company, I saw a pneumatic press inserting roller bearings into the caster wheels by using a large pneumatic cylinder. Pressurized air was used in both directions of the operation, the force cycle and the return cycle. Unfortunately, the high-pressure air in return cycle was unnecessarily wasting so much air. In one of my videos, I showed you how a 4-way 5-port air valve can be used to reduce excessive air consumption in the return stroke. In this video I will show you another way. Since the return cycle does not require too much force, we could use a single acting spring return cylinder to prevent excessive air use in the return stroke. However, it is usually harder to find a large single acting spring return pneumatic cylinder, and they may also be expensive. As you can see in this video, we can convert a regular double-acting cylinder to an air spring return single-acting cylinder. To do this, we take a large empty propane tank and connect it to a double-acting cylinder's return port. A pressure regulator connected to the propane tank keeps the pressure in the tank around 1.15 atmosphere. Also, a pressure relief valve attached to the propane tank makes sure that the pressure in the tank does not exceed a predetermined pressure, for example 1.4 atmosphere. Once the tank is filled and there is no air leakage, the air inside propane tank acts like a spring. In this circuit, 6-bar pressurized air is represented with red color, the blue colors show atmospheric pressure and the light green colors show confined air, which act as an air spring. The pressure of the confined air changes between 1.15 to 1.4 atmosphere depending on the location of the cylinder piston. Notice that when the operator pushes the push button on the 2-way 3-ports normally closed valve, it actuates another similar kind of valve which sends pressurized air into the working port of the large cylinder. This forces the piston inside the cylinder to move forward. This forward motion increases the pressure of the air in return part of the cylinder to increase. However, the pressure of the force cycle is high enough to overcome this increase in pressure and also push the bearing to its assembled position. As soon as the push button is released, the pressure inside the return part of the cylinder pushes the piston rod backwards. Since the air inside the propane tank is not replenished, this prevents pressurized air waste. Notice how the pressure in the tank is increasing when the piston doing the force cycle and decreasing in the return cycle. Notice the highest pressure reached at the end of the power stroke is 1.374 atmosphere. Even though the circuit saves pressurized air in the return cycle, it is wasting too much air during the forward cycle. This is because the cylinder has a longer stroke. If we reduce the stroke, the volume to be filled with pressurized air will decrease, and this enables us to save pressurized air. Let's put caster closer to the cylinder so that power stroke becomes shorter. As you can see, the pressure inside the propane tank is not increasing as much. One should use a short power stroke as much as possible so that each power cycle becomes more efficient. Thank you for watching our videos. We encourage you to subscribe to our channel and rate our videos. Thank you.